Okay, so I'm Carnatan Villarubia, and I will be discussing the assignment number 5 in machine elements. So as for the given, this kinematic diagram is on a 4 cm, 4.5 cm, 3 cm, and 6.5 cm, and we from the given numbers we will be computing the velocity of this one that is rotating at 600 rpm, and you'll get 1.885 meters per second. And then as we compute that, we will now put that in the velocity analysis, which is this one. This one is the VB, and then get the tangential of this one. This one is the tangent or the perpendicular line of this one is this one, and then the link DC from C to D, that is the perpendicular, and from C to E the perpendicular is this one, like this. And so in computing for the velocity analysis, you'll just use the scaling or the ratio, which is 1.885 meters per second to 3 centimeters, and then we will convert it to get the velocity of each velocity of the links as it moves. So now moving forward for the acceleration analysis, the normal acceleration formula is this one: v squared, or the velocity squared divided by the radius. Then our scale that we will be using is 1 cm is equals to 20 meters per second squared. So in computing the acceleration, we get all of these values, and then once we get all of those values, this one is from the tangential movements of the acceleration or the mechanism. And in plotting all of that, we will get that the acceleration of E moves at a 1.1 cm, which is, when we put it in our ratio, is equals to 22 meters per second squared. So in number 2, this given kinematic diagram here is our scaling is 20 millimeter to 1 tm. So I use the compass to accurately measure all of the links together. This one is 45 degrees. And then in computing for the velocity of the crank moving at 600, or moving at a speed of 60 rpm, the velocity that we will be getting is 1.885 centimeters or meters per second. And in computing for the velocity of each one, this will be our, when plotting the perpendiculars, it will be our velocity diagram. And then getting the acceleration is just the same of this one. The computing for the AP, we'll get AP is equals to 580 millimeters per square second